Okay. So see, first we try to understand what do you mean by the coordination chemistry. Okay. So at the beginning of the unit, we are talking about say the number of bonds we learn in chemistry. Okay. So in case of chemistry, we learn four types of bond. Okay. The first one is what covalent bond, which is formed due to the sharing of the electron. Okay. Second is nothing but the ionic bond, which is formed due to the complete transfer of the electron from one species to the other. Best example is nothing but the SCl or the NaCl molecule. And ionic bond is just an interaction in between what the positive and negative spaces. Okay, so we are not going to assume that assume that this one is what bond. So it just an what interaction in between the positive and negative spaces. Third type of bond is nothing but the coordinate bond. Okay, so coordinate bond. So we try to understand what do you mean by the coordinate bond. Coordinate bond is nothing but say it is just an see in an example the bond formation in between the NH3 and you can say that the SCl molecule. So when we are going to react ammonia with HCl, so it's an acid-base reaction. Here, what happened? Ammonia, they're having nitrogen. Nitrogen is having what a lone pair. Okay, so this lone pair can act as a Lewis base. Okay, and they can attack over that proton, which is electron deficient. And there is a formation of bond in between what nitrogen and hydrogen. Okay, so this bond is nothing but said to be the coordinate bond. Why? Because both electrons are say coming from nitrogen atom. Okay, and it is equally shared in between the nitrogen and hydrogen atom. So that bond is nothing but the coordinate bond. We further discuss in our next slide. Okay. So whatever the compounds, those who form by the combination of such type of bond, which we call as coordination bond, that compounds are called as coordination compounds. Means the compounds where we have the coordinate bond. Okay, that bond or that compound are nothing but said to be the coordination compounds. Okay, so now we move towards what, yeah, this slide. This one is what our first definition is nothing but double salt. Okay, so here we have two types of entities over here. The first one is what double salt and another is nothing but the coordination compound. Okay, so the question can be asked over to differentiate the double salt and coordination compound. Okay, so see here this double salt is nothing but said to be this one. Okay, so we know about what this compound. This is an, you can say that in Marathi we can call as what turti, in Hindi we can call as what the fitkari, and in chemical language we can call as what say the potassium. Okay, so this is an what to say the double salt. Okay, so now we try to understand what do you mean by double salt. So double salt is nothing but said to be the compounds which contain more than one cation or anion. Okay, the best example is nothing but this one called as what say the potash alum, having formula is nothing but this one. That is what here we have what two cation. So this is what say the potassium. Potassium is what positive, and this one is what Al. That is what the aluminum, which is present in the 3+ state. Potassium present in the 1+ state. Okay. And this is what say the SO4, and they're having what say the hydrogen molecule is there. Okay, so combinedly when we study this or when we observe this chemical formula of potassium, so we observe here there is a presence of two atom, two metal. Okay, means this first one is what say the potassium, second is nothing but said to be the aluminum. So what is double salt? Double salt is nothing but the compound which contain more than one cation or anion. Okay, and what is the you can say that the property of double salt. So when we dissolve this double salt into our you can say that water or any aqueous medium, so what happens, that double salt they can you can say that soluble into the water or the aqueous medium. And when we test that solution for a particular metal, for example, suppose if we suppose dissolve this potash alum into the water. Okay, and we are going to now taste of what say the potassium and aluminum. So when we take a water, okay, and then we do the test for potassium. So that solvent, or you can say that that solution, it give the taste of what potassium as well. When we do the same with what aluminum, okay, so that solution also give the positive taste for aluminum. It means that double salts are nothing but those compounds when we dissolve in water, okay, so they can after the dissolution in water, their cations are going to free, okay, means they have their own identity. So that's why we write over here the double salts are completely dissociate into the simple ions and give the taste of each other and every ions. Okay, so this is nothing but said to be yeah, the double salt. So what is double salt? What we have to remember regarding the double salt? So double salts are nothing but the compounds which can be made by the combination of more than one cation or anion, okay, and when we dissolve into them. So this is what say the preparation of the potash alum. We can prepare this in our laboratory also. So we get what a potassium sulfate, okay, which having the molecular weight 174, and aluminum sulfate, okay. So here we are going to say take two different chemicals, that is what potassium sulfate and aluminum sulfate, okay, plus water, and when we heat it, so we got a complex, you can say that the compound which having molecular formula is what K2SO4 Al2SO4, and combinedly it should be written as what this one, that is what KlSO4 by 2. Okay, so this is called as what the potash alum, which is an example of double salt. Okay, so in simple language, what is double salt? The compound which can be made by the combination of one or more than cation or anion, okay, and when we dissolve into the water, so it gives it gives the taste of each and every ion. Okay, so that compounds are called as what's the double salt. Best example is nothing but said to be the potash alum. Now we talk about coordination compound. Okay, so here we have to differentiate both, that is what double salt and coordination compound. So now this is what coordination compounds, where we already talk about the coordination bond. So here the coordination complexes is a product in between the Lewis acid and base reaction, okay, in which the neutral molecule, neutral or say to be the anion ligand, they are bonded to the central metal ion. Okay, so I will tell you about what the coordination complex is. So see, in case of what coordination complex, we have what metal. Okay, so I will say show this reaction. So this is in, I think what's said to be the nickel, okay, which is present in the dipositive state, okay, and we have the aqueous solution of the nickel, okay, so this one. So when we add what say the ammonia into it, so the we are going to add the aqueous ammonia into it, so we got what such type of complex, so which is what a light green. So first of all, say the color of this solution is must be different. After the addition of this ammonia, okay, the color of the solution becomes changed, and we got what's the light green color. So we can say that what our complex will going to, our complex will going to say form. Okay, so see here what we got in first interaction, we got what say the nickel hydroxide, which having the light green color, okay, and when we add the excess ammonia into it, so what we got what the hexaamine nickel 2, okay, hexaamine nickel 2, which is in blue color solution, okay, blue color solutions, and after what suppose the freezing, we got what's the precipitate of this one. Okay, so now we have to understand what do you mean by the coordination compound. So coordination compounds means what here, this is nothing but said to be the metal which can provide the empty orbitals. Okay, empty orbitals means they don't have electron. Okay, then when we reacted such type of metal with say this NH3, okay, so it is nothing but said to be the ammonia. Okay, so this nitrogen is having the lone pair present over here. Okay, so we have two entities over here, that is what Lewis acid and Lewis base. Okay, so according to the Lewis theory, the compounds who donate the electron pair, that will be the Lewis base. Okay, and the compounds which has ability to accept the lone pair, so that compound is said to be the Lewis acid. Okay, this base is nothing but the electron donor, and acid is nothing but said to be the electron acceptor. Okay, so when we have what say the metal, so the metal can provide the empty orbitals, means they are able to accept the electron pair. That's why metals are said to be the Lewis acid. Okay, and here, so we are going to call as what the ligand. So what is ligand? Ligands are nothing but said to be the any positive, negative, or neutral species. Which one? Positive, negative, or neutral species. Okay, having ability to donate the electron pair to the metal. Okay, means they have the lone pair and they can donate to the what metal. So such type of species is said to be the ligand. Okay, so in case of what coordination compound, two things are most important. So the first thing is nothing but the Lewis acid. Okay, so who is Lewis acid? The metal is acts as the Lewis acid because they have the empty orbitals. Okay, and they are able, they have tendency to accept the electron pair. That's why it acts as the Lewis acid. Another is nothing but the ligand. Okay, another is what say the ligand. Ligand has tendency. So three types of ligand we have, either positive, negative, or neutral is there. Okay, positive, negative, and neutral is there. Okay, so three types of ligands we have. And what is the function of ligand? Ligands are able to donate the electron pair towards the metal. So that's why this is a characteristics property of a ligand. Okay, so this is all about what say the two different things present in the coordination chemistry. First one is the Lewis acid, means the metal ion. Another is the Lewis base, means what say the ligand, which may be either positive, negative, or neutral. Okay, so now we are going to think about what say the bonding in between the metal and ligand. Okay, so when we have what say the metal which having the empty orbitals, another we have what say the ligand which having what say the field orbitals, or they say that the electron pair present for donation or available for donation. Okay, so when this one is what said to be the nickel, okay, which is present in the dipositive state, is reacted with what say the NH3. So here nickel is nothing but said to be the Lewis acid. Okay, because they provide the vacant orbital. Okay, and when this nickel solution can interact with the ammonia, so here ammonia acts as a what ligand, because they have what say the electron pair present over nitrogen atom. So as we add this ammonia solution into what say the nickel, so we got what first the nickel hydroxides which having the light green color. Okay, after the addition, after the excess addition of the NH3, we got what say the blue color solution, which is called as what's the hexaamine nickel 2. Hexa what? Because we have 6 NH3 over here, so we can say that hexaamine NH3. NH3 is called as what amine, and hexaamine nickel, and this is what say the 2 means what their oxidation state. Okay, so this is nothing but this one complex in which so you can say that in which this nickel is bonding to the what nitrogen. Okay, so there is a bond formation in between what say this nickel and this you can say that this ammonia or nitrogen. Or you can further we can add, suppose what we take what say the same solution of the nickel and we can add what say the concentrated ammonia into it. So finally we got what say the blue color solution over here. Here in this diagram we show what say the structure of this nickel hexaamine nickel 2. Okay, so this centrally situated, this one, okay, so this one is centrally situated, it is called as what say the central metal ion. Okay, it is called as what the CMI, central metal ion, CMI, which is then positively charged. Okay, and these are nothing but said to be the 6 say species shown over here. So this first one, second one, third one, and fourth one, and fifth one. So these are nothing but said to be the ligands. Okay, this one is called as what say the ligands. So the 6 ligands, they are surrounded by means of what say the metal. Okay, so they have what two positions. The first one is nothing but said to be this axial position. This vertical position is called as the axial position, and this one is nothing but said to be the equatorial position. So sometimes we can say that what is the equatorial position. So when we talk about what's the bond in between what this metal and this ligand, so that bond is nothing but said to be the coordinate bond. Okay, or sometimes they can be treated as what's the ionic bond. Okay, so there is a coordinate bond in between them. Why coordinate bond? Because both electrons required for the bond formation is supplied by means of what's the ligand. Because the metal they don't have electron. Okay, so that the ligand will going to provide a electron in between the bond formation of the nickel and this NH3. And finally, we got what such type of complex. This is an octahedral complexes because the number of ligands are nothing but 6. Okay, so the next when we compare this coordination compounds with what say we can say that with double salt. So in case of the double salt, when we dissolve into the aqueous solution, so they gives the taste of all positive and negative ions. Okay, so when we suppose in case of what's the coordination chemistry, when we suppose dissolve this coordination complex in water, okay, and when we are trying to do the test for particular metal, means here we have what this one, that is what the nickel NH3 hexamine nickel 2. We can take this complex blue complex, dissolve into the water, and we try to do the test for what say this nickel, okay, by means of what say the DMG, that is dimethyl glycine. Okay, so that complex or the solutions will not going to give a positive test for what's in nickel. It means that here no means the identity of what's this metal will going to lose whenever was say the coordination complex is formed. In case of what's the double salt, the identity of the metal will remain after the formation of the double salt. Okay, means there in case of what's the double salt, the identity will not suppress, and here is nothing but identity will going to be suppressed. Okay, so this is what's the main difference in between the coordination compound and double salt. Yeah, this question is asked many more times in examination. Okay, so the difference in between the double salt and coordination compound. So first we have what say here in case of the usually contain 2 or more salt in equimolar proportion. So as we already talk about the preparation of say the potassium, we have say the potassium sulfate as well the aluminum sulfates when we take in equimolar proportion. So we got the potassium. Okay, and here uh, here we have what say the only one salt will be present over here. Okay, why? Because only one metal we have in coordination complexes. Here they exist only in the solid state, and in aqueous solutions they are dissociated completely. Means double salt are only exist in the solid state. When we dissolve into the what say the aqueous phase, their identity will go into loss. Here in case of the coordination complexes, they may exist in the solid as well as in the aqueous solution. Okay, means they lost their you can say that the identity. They are ionic compounds and they do not contain any coordinate bond. Yes, means the double bonds are nothing but said to be the ionic compounds. Okay, and they do not have any coordinate bond. But in case of the coordination compound, they may or may not be ionic. Okay, yes, they sometimes they are ionic or they may not be ionic, but you can say that they must contain what's the coordinate bond, as already told you. The properties of the double salts are the same as that of the constituent compound. So what do you mean by that? Suppose we take what we're going to prepare what's the potassium by mixing what's the potassium sulfate and the aluminum sulfates. Okay, and suppose we got what's the potassium, we dissolve into the water. Suppose we get a test for what's the potassium from what's potassium sulfate and potassium. So we got what's a test from both. So that's why the properties of what say the double salt is exactly similar to the properties of their reactant. Is the properties of the potassium is similar to that of what say the potassium as well as what say the aluminum sulfate. But in case of the complex compound, the properties of the complex compound is different than that of what their constituent ion is, what their reactants. Okay. The next is nothing but in the double bond. In the double salt, the metal ion shows their normal valency. So obviously we know that metal ion they can show their normal valency, but the same thing not say possible over here. We have two types of valency. That is what say the primary as well as what say the secondary valency. So we will going to discuss in the coordination chemistry. Here next point is what the double salt loses its identity in the solution. Okay.